Hey guys, today we are factoring polynomial equations. So let's go through a factor U. These should be familiar to you from chapter 1 and are practicing there. So when we factor, we're looking for two numbers that multiply to -6 and that add to a +5. So I would say 6 and -1. So 2x squared plus 6x minus 1x minus 3. So then I can take a 2 out front, or 2x out front, and I have x plus 3. I can take a -1 out, and I have x plus 3. So I have 2x minus 1, and I have x plus 3. And we're finished with that one. That x squared minus 64 is one of our special patterns. That's a difference of two squares. So we have x plus 8 and x minus 8. Remember, you just take the square roots, make one a plus, one a minus in between those. What I want to look for here, though, is I see that all of those numbers are even, so I know I can at least take a 2 out. I also see that every term has an x, so I can take a 2x out front, and then I have 2x squared minus 6x, or no, minus 3x now, if I take a 2 out of there, and plus 6. So then I want to look, do I have something that multiplies to a +12 and adds up to a -3? So things that multiply to 12 would be 1 and 12. That won't work. 2 and 6, that won't work. 3 and 4, that also won't work. You can check it by the discriminant, but that's going to be our final answer if there is nothing else that we can factor out there. Okay, so some more special patterns. A difference of two squares we just talked about is a plus b and a minus b. The sum of two squares we talked about before. We didn't have a way to do this. Now that we know imaginary numbers, this is a plus bi and a minus bi. Then a cubed plus b cubed and a cubed minus b cubed. So the sum of two cubes and the difference of two cubes. So here's what I remember. You have two terms here, you have three terms here. This is an a, this is a b, this is an a squared, this is an a times b, and this is a b squared. I think of the word soap. This works for both the sum and the difference. So this is for the signs here to help you. So SOAP is just a little acronym to help you remember what sign to put here. So you're going to put the same sign that you see in here. So since this is a sum, I'm going to put a plus sign. O tells me I'm going to use the opposite sign. And then AP means this is always positive, so I'm always going to put a plus sign there. It works the same down here. I'm going to put an A, I'm going to put a B, I'm going to put an A squared, I'm going to put an A times B, and I'm going to put a B squared. Then for my sign, same sign, opposite sign, always positive. That second trinomial that you see there, or the only trinomial you see there, will not factor with this sum of cubes or difference of cubes. So factor using real coefficients. So that means we are not going to take it out to the imaginaries at this point. We're factoring using real coefficients. So 125 plus x to the third. So that's a sum of cubes. So if a equals the cube root of 125, that's 5. And b equals cube root of x cubed is x. So I'm going to put a, which is 5, b, which is x. Then I need a squared, which is 25, a times b, which is 5x, and b squared, which is x squared. And I'm going to think SOAP. Same, opposite, always positive. All right, and part B, I need to look to see if there's anything I can take out of there. So 64 and 27 don't have any numbers in common, but they do both have an a that I can take out. So I have 64a to the third minus 27. Now it looks like a difference of two squares with this a up front. So this should be a 64a to the third. So my a value here, the cube root of 64, is 4a, and my b value here is 3. So I have that a out front. Then I have 4a, and I have 3. Then I have 4 squared is 16a squared. Then I have 4a times 3, so I have 12a. And then I have 3 squared, which is 9. Same sign, opposite sign, always positive. That's how I fill that in. The a still has to stay out front. Okay, then looking at part C, I have 8x to the 5th plus 216x squared. Well, if I start doing some math here, I see that I can take an 8 out, and I can also take an x squared out. So if I take 8x squared out, then I'm left with x to the third, and 216 divided by 8 gives me 27. I still have a plus sign in between. So my a value is x, my b value is 3. So I have this 8x squared out front, and then I'm going to use x, I'm going to use 3, I'm going to use x squared, I'm going to use 3x, and I'm going to use 9. Think so. Same sign, opposite sign, always positive. All right, on part D, I have the difference of two cubes again. So I'll go ahead and slide that up so we can see it. So difference of two cubes, my a value is going to be 5y. My b value is going to be 4. So I have 5y and 4. And then I have 25y squared. And then I have 20y. And then I have 16. Same sign, opposite sign, always positive. All right, now I have a to the 4th minus 256. So that's not a difference of two cubes. I have a 4th power there. But that's still a difference of two squares. If I look at this, I can take the square root of a to the 4th, that's a squared, and I can take the square root of 256, and the square root of 256 is 16. So I have a squared plus 16, and then I have a squared minus 16. So it did say to write it with all real coefficients. So that a squared plus 16, I could factor out, but we're not going to at this point. So we're going to leave it as a squared plus 16 since it said leave it as real coefficients. And then a squared minus 16 is another difference of squares. So I could do a plus 4 and a minus 4. If it had said we could factor it out all the way, then this would be a plus 4i and a minus 4i, and then a plus 4 and a minus 4. So this one says rewrite as a product of linear factors. So this is where we'll take it all the way out. So we have x squared plus 4, and we have x squared minus 4 in this case. So our x squared plus 4 is x plus 2i, x minus 2I, x plus 2, and x minus 2. We have 256y to the fourth minus 81. Well, if I take the square root of each of those, I get 16y squared plus 9, and I get 16y squared minus 9. So then to take each of those down, I get 4y plus 3i, 4y minus 3i, then I get 4y plus 3, 4y minus 3. So there's your linear factors when you multiply that all out. Or when you divide all of that out, factor it all. So then factoring by grouping is something we talked about before. So we're going to factor by grouping here, looking at the first two and the last two and seeing what we can take out of there and seeing if we can then simplify it down. So if I look at these first two, I can take an x squared out of the front and put it out in front, and then I'm left with 2x and a minus 1, and then I have nothing that I take out of the second one, and I'm left with 2x minus 1. So from here, x squared plus 1 times 2x minus 1. Now, we can split out that x squared minus 1 into x plus 1i, or x squared plus 1, x plus 1i, x minus 1i, and then 2x minus 1. And that will be your final answer for that one. On this one, I can take out an x squared, and I'm left with x plus 4. And then I can take out a minus 9, and I'm left with x plus 4. So x squared minus 9 times x plus 4. Then I can simplify that x squared minus 9. Since it's a difference of two squares, we're dealing with the real, so x plus 3, x minus 3, and then we still have x plus 4 that needs to come down along with it. And there's your final answer simplified down. Alright guys, that's all I have for you on this one. So if you have any questions, please feel free to come see me. Otherwise, I'll see you in class.